Hi, today we're doing congruence in right triangles, 4.6 on page 235. So the first thing that we are presented with is a right triangle. Okay, a right triangle obviously is never to be assumed as a right triangle unless you're told this is a right triangle in words, or if you've got that little square in the corner. If neither one of those two things are present, the triangle is not a right triangle. Okay, so a right triangle, obviously because it's a triangle, it has three sides, but because it's a right triangle, the one special side that it has that no other type of triangle will have is this longest side right there. And that is called the hypotenuse. Okay. Okay, and when we start to work with right triangle trig, we'll utilize the fact that that is the longest side of a right triangle no matter what. So that's the hypotenuse, and these other two sides are called legs. Okay? So a right triangle is made up of two legs and the hypotenuse. The hypotenuse is always the side across from the 90-degree angle. Okay, so we'll move on to theorem 4.6. Theorem 4.6 talks about right triangle congruence. It says if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Now, what that theorem does not use is the word corresponding. So, for example, if the hypotenuse of the triangle on the left is congruent to the hypotenuse of the triangle on the right, we're all good. However, if this side on the triangle on the left is congruent to that side of the triangle on the right, that is not the HL theorem. The legs have to be corresponding legs. So that would be right triangle congruence. Or this would be right triangle congruence, okay? We need to make sure that we understand that the word corresponding as far as the legs go is very important. Okay, so we're looking at quick check 1. And what we're doing here is naming the two triangles that are congruent by the HL theorem. And that is the hypotenuse leg theorem, which is theorem 4.6. Again, HL, hypotenuse leg. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the corresponding leg of another right triangle, then the triangles are congruent. So let's just reiterate, theorem 4.6 is the HL theorem, hypotenuse leg. Okay, so when we look at quick check 1, it says which two triangles are congruent by the HL theorem, and write a correct congruence statement. Okay, so what we're going to do, because the easiest part to identify in each one of these is the hypotenuse. Okay, so it looks like in triangle LMN, the hypotenuse is 5. It looks like in triangle QOP, the hypotenuse is 5, but the hypotenuse in triangle SRT is not 5. The leg is 5. So the two triangles that are congruent are the first one and the second one. And writing the triangle congruence statement is just as important here as being able to identify the congruent triangles. So triangle LMN is congruent to triangle OQP. Okay? That's your triangle. And we could, you know what, maybe it'd make more sense to start with the right angle in both cases. Okay? Just maybe because it'll be easier to designate which way you need to go around the triangle in order to get the triangle congruence statement correct. Okay, so we'll start with the right angle. So triangle MLN. So we started with the right triangle, and then we went to L, which utilized in our statement the side that had a length of 3. So we can use that same logic as we write the other triangle, starting with the right angle and going along the side measured 3, which would give us the vertex O and then P. Okay, so MLN is congruent, if triangle MLN is congruent to triangle QOP by the HL theorem, okay? The base of each measures 3, and the hypotenuse of each measures 5. Okay, now what we're going to do is, instead of doing quick check 1, we're going to do the proof in example 2. Now, if you look on the bottom of page 236, the type of proof that they have utilized is a flow proof, and I despise those. I find them very difficult and very confusing to write and also to follow, because they just go everywhere with these arrows everywhere. You don't know, well, what arrow am I following first? So we're going to use a 2-column proof, and we're going to prove that triangle CBD is congruent to triangle EBA using that illustration, the given and the prove, and a 2-column proof instead of a flow proof. All right, so I wrote the statements and given just to save a little time right there. So what we're going to do right now is mark up the illustration according to the given. We have CD right here is congruent to EA right there. That's what we know so far. The other thing that we're told is that segment AD, which is this one right here, the whole entire thing, is the perpendicular, there's your perpendicular symbol, is the perpendicular bisector of CE. Okay, so let's review perpendicular bisector. If AD, first off, is perpendicular to CE, what it does is it leaves a right angle right there. Okay, also right here. That's the perpendicular part. Now, the bisector part is when the AD segment cuts CE directly in half. So, right there and right there. Okay? So, what we know because of the perpendicular bisector is what leads us into statement 2. We already know that CD and EA are congruent. Those are marked with the little red tick marks there, okay? We marked CB and EB as being congruent, and that is because of the consequence of AD being the perpendicular bisector. So we're told AD is the perpendicular bisector, but because of that, we have another statement that we can make. So statement number 2, as marked on the triangle, is segment CB is congruent to segment EB by definition of perpendicular bisector. Now, that is not the only thing that results from the perpendicular bisector. All we did so far was talk about the bisector. That's CB and EB. We also have to talk about the perpendicular part, okay, which tells us that angle CBD is congruent to angle EBA. And that is the same reason, but this time we're pinpointing in particular the perpendicular part of that statement. Okay, so AD being the perpendicular bisector of CE led to statements 2 and 3. Now, if you look at the illustration, we've got it marked up where we know that they are right triangles. So that is something that we need to say. You can't just go on and use the HL theorem without first saying that the triangles are right triangles. So we're going to say that triangle CBD and triangle EBA are right triangles. And that is the definition of a right triangle, because it's got that 90-degree angle in there. Okay? Now, statement number 5 allows us to say that triangle CBD is congruent to triangle EBA by the HL theorem. Okay? And we could have well, no, I guess not, because we didn't know that CE was the perpendicular bisector of AD. That's we weren't given that. Okay, so the leg that we have as being congruent is CB and EB. That's the L part of HL. And of course, the hypotenuse was part of our given statement. Okay, so let's clarify. In order to be able to use the HL theorem, you need to first prove that the triangles that you're working with are right triangles. Okay? And we could have even thrown in here, I'm going to throw in 3A, let's say, or let's say 3B. Okay? Angle CBD, and actually that would go right up in here, and angle EBA are right. Okay? That would probably be the better way to make statement 3. Okay? That would be the better way, actually, to make statement 3. Would be just to say that angle CBD and angle EBA are right, and the reason would remain the same. That would actually be the better way to do that. See, these aren't just this is not just a brainless procedure for me either, okay? After I looked at what I had written, I had to kind of revisit. Well, if I'm saying they're right triangles, I have to say that those angles are right angles first, which led me to getting rid of this part right here and keeping that part right there. Okay, sorry. Had to just move it a little bit, and it's still kind of crazy. Anyway, there you have it. Okay? You have to prove that the triangles are right triangles before you can use the HL theorem. Okay, now we've got one more proof here, and sorry to say, but there is no IXL for right triangle congruence. I did look, and we've got right triangle trig in IXL, but no right triangle HL theorem congruence stuff. So there will be bookwork, there won't be any IXL, and I guarantee you there will be proofs. Okay, so for quick check 3 on page 237, that is what we're given, the illustration. We're given that angle PRS and angle RPQ are right. Okay, so I'm going to write statements, which I should have already done to save time, and reasons. And it wouldn't, of course, be a bad idea for you to write this down along with me. So when you have to do these in your homework, you have a place to start and something to refer to, okay? Because yes, there is a proof that is written out in example 3, but of course, as from what I can determine from what I hear from you guys, you can't practice these too much. Okay, now we're going to go back and mark up our illustration according to the given. Angle PRS is a right angle. That's right there. See, PRS. Okay, that is a right angle. Likewise, angle RPQ. That's given. Okay, well, what does that, was that all that was given? Oh, I forgot to write something. I was going to say this isn't going to make any sense at all with the rest of the given. So let me move down my proof part a little bit here, and I can write in, and of course I missed some of it. That's okay. RPQ. We have another given statement that I completely missed, and I was wondering, again, that's not going to work. We are also given that SP is congruent to QR. Now that is going to help us. That one statement alone got us absolutely nowhere. So SP is congruent to QR. And if you notice, SP and QR are the hypotenuses of those two triangles. Okay, so now what we're going to do is, yes, we were told that those two angles are right angles. But remember, if we're going to use the HL theorem, we have to say that the triangles are right triangles. So the first thing that we're going to say is triangle PRS and triangle RPQ are right triangles. And the reason is definition of a right triangle. A triangle is only a right triangle if you've got right angles. So statement 2 was made because of what we were told in statement 1. Yes, we were told that the angles are right angles, but before you can use any HL theorem, you have to say that the triangles are right because of the definition of the right triangle. All right, so now we know they're right triangles. Okay, and we were already told that SP, I need to write that in the given as well, SP is congruent to QR. That was also part of the given, okay? And the illustration is marked up accordingly, and we have stated then that the two triangles are congruent to each other, all right? If we use the HL theorem, there's only one more side that we need to be able to mark as congruent. And if you notice, PR is that third shared side in each triangle. Therefore, it is congruent to itself. And that is the reflexive property. Okay? And remember, I said it before and I'll say it again. We will use the reflexive property over and over and over again. Okay, now we have the triangles marked up, and we can safely and accurately say that triangle PRS is congruent to triangle RPQ because of HL. The hypotenuse right here, each one congruent to each other, and PR, the leg, obviously is congruent to itself by the reflexive property. Okay, so this last page is going to be the page where you hear what your homework is. And Mr. Asher will have this as well. So pages 238 and 239. And I'm going to change colors here because that's a little bit difficult to read. 238 to 239, 1, 3, 5, 7, 11, 13, 21, and 23. Okay, not too bad. And yes, there's proofs. Okay, guys, work hard.